A woman at a point A on the shore of a particular lake with a radius 2 miles wants to arrive at the point C directly opposite A on the other side of the lake. She can walk at the rate of 4 miles per hour and row a boat at 2 miles per hour. And we want to know what angle theta she should row across the lake at. This is theta right here. To both minimize and maximize her travel time. She's in a hurry. We want to figure out how she should row to get across as fast as possible. And then if she wants to take a slow scenic journey, what angle theta will maximize her travel time. So we've got a couple of hints here. It says angle ABC. So if I draw that in, we've got a right angle. And angle BOC, that's this angle here, is 2 theta. So those two pieces of information come from theorems in geometry. Maybe you remember them, maybe you don't, but that's why we gave them as hints. Okay, so the smallest her angle theta could be would be 0 if she just rows directly across the lake. So theta, the smallest it can be is 0. And if she were to walk all the way around the lake, that corresponds to a theta value of pi over 2. So in that interval, we want to minimize and maximize travel time. Okay. So for a generic theta, we need to know this distance and this distance, because she's going to row here and then walk along this curve the rest of the way. So let's first work on the rowing distance. How long is that? That's where the right angle comes in. So this side is the hypotenuse, and it has a length of 4. And this side is the side adjacent to theta. Let's call it x. So the cosine of theta is going to be x over 4, up adjacent over hypotenuse. And that means that x is 4 cosine theta. So the distance that she's going to be rowing is 4 cosine theta. And if she can row at 2 miles per hour, then we take that 4 cosine theta and we divide by 2 to get time. So time rowing is the distance she rows divided by 2 miles per hour, divided by her speed rowing. All right, so that's the time spent rowing, and then we got to figure out how much time she spends walking. So I'm going to erase what I have here. And the next thing I'm trying to figure out is the length of this arc from B to C. So that's where the angle BOC being 2 theta comes in. Because that's like a slice of pi. The whole pi is 2 pi, and we have 2 theta of it. So 2 theta out of 2 pi. So the angle of our slice compared to the entire circle, which is 2 pi radians. So that fraction of the circumference is the arc BC. So the entire circumference of the circle is pi times the diameter, or 4 pi. So let's see, those 2's cancel, the pi's cancel, and I get 4 theta. That is the length of arc BC. Okay, so then the time walking is equal to the distance walked, which is 4 theta, divided by the speed you can walk, which is 4 miles per hour, and that is theta when the 4's cancel. Okay, so I have time spent rowing added to time spent walking. That I now have a function for how long it will take to get across the lake, combination rowing and walking. So my total time function is the sum of these two. Let's cancel those and put a 2 there. So I have 2 cosine theta plus theta. So if I want to minimize or maximize a function, we are going to look for places where the derivative of the function is 0. So t prime is -2 sine theta plus 1. Taking the derivative with respect to theta. And we want to set that equal to 0 and solve. Okay, so I get sine theta has to equal 1/2. And I'm only looking for angles in this interval from 0 to pi over 2. The only angle in that interval where the sine of theta is 1/2 is pi over 6. So now I just have to look at my critical value and my endpoints, calculate the time at each of those, and see which is a min and which is a max. Okay, so let's see, I'll calculate t of 0. So t of 0, that would correspond to rowing directly across the lake. T of pi over 6, that would correspond to rowing at an angle of pi over 6 and then walking the rest of the distance. And finally, t of pi over 2, and that would be, if we make this angle pi over 2, there would be no rowing at all and we would just walk all the way around the lake. Okay, so when I plug these things into the original function t, 0, pi over 6, and pi over 2, I get t of 0 is 2. T of pi over 6 is approximately 2.255. And t of pi over 2 is 1.57 approximately. So that means that pi over 2 yields a min. And pi over 6 is the max. So we found the minimum travel time and the maximum travel time.